NASA just chose 4 new moon missions to build a permanent lunar base. Source: NASA announcement, Moon Base Program. For more than half a century, the moon has represented humanity's greatest unfinished journey. We first reached its surface in 1969, planted our footprints in the lunar dust, and then, after only a handful of missions, we left. For decades, the moon remained quiet, a destination remembered more as history than as humanity's future. But that era is rapidly coming to an end. NASA has now announced 4 major new lunar missions that could transform the moon from a place we occasionally visit into humanity's very first permanent home beyond Earth. If you like my videos, subscribe my channel and press the bell icon to turn notifications on so you keep getting all the major advancements in science and technology. And don't forget to like and share this video with your friends and colleagues. Comments are welcome and open for discussion. In a major step toward that goal, NASA has awarded nearly $600 million in contracts to 3 commercial space companies: Astrobotic, Firefly Aerospace, and Intuitive Machines. Together, these companies will carry out 4 commercial lunar landings, all scheduled for late 2028. These missions are part of NASA's rapidly expanding moon-based program, an ambitious effort designed not simply to explore the moon, but to establish a long-term human presence there. Rather than building and operating every spacecraft itself, NASA is increasingly partnering with private industry, allowing commercial companies to develop lunar transportation, while the agency focuses on science, exploration, and the technologies needed for future astronauts. This marks another major milestone in NASA's Commercial Lunar Payload Services, or CLPS, initiative. Instead of treating each moon mission as an isolated event, NASA is building a transportation network capable of delivering equipment, scientific instruments, and eventually the infrastructure needed for a permanent lunar settlement. The newly selected landers are upgraded versions of spacecraft that have already flown or are currently under development, allowing engineers to improve reliability while increasing the pace of exploration. NASA officials describe this approach as building a proving ground, launching missions more frequently, learning from every landing, refining designs, and steadily moving closer to sustained operations on the lunar surface. The financial investment reflects the scale of this effort. Astrobotic received approximately $298 million to carry out 2 separate moon deliveries. Firefly Aerospace was awarded about $144 million for 1 mission, while Intuitive Machines received roughly $148 million for another. Altogether, the contracts total nearly $600 million, demonstrating that NASA is committing significant resources to establishing a permanent lunar infrastructure rather than conducting occasional scientific expeditions. Although these missions will land in different locations, every lander will carry the same 3 carefully selected scientific instruments. This standardization allows scientists to compare measurements collected from multiple regions of the moon, gradually building a much more complete picture of the lunar environment. One of these instruments, called SCALPS, uses multiple stereo cameras to create detailed 3-dimensional images of how a lander's rocket engines disturb the lunar surface during touchdown. Every landing blasts enormous amounts of dust and debris into the surrounding area. As future missions become larger and multiple spacecraft begin operating close together, understanding exactly how this dust behaves will become essential for protecting nearby equipment, habitats, and astronauts. By studying different landing sites, engine designs, and landing conditions, scientists hope to develop accurate computer models that predict how lunar dust moves during future missions. A second instrument, known as the Laser Retroreflector Array, is much smaller, but could become one of the moon's most important navigation tools. Roughly the size of a cookie, this passive device contains specially designed quartz prisms that reflect laser beams sent from orbiting spacecraft or incoming landers. Because it requires no electricity, moving parts, or maintenance, it can remain on the moon indefinitely, serving as a permanent location mark. Over time, NASA plans to build an entire network of these reflectors across the lunar surface, giving future spacecraft increasingly accurate reference points for navigation and precision landings. Much like GPS satellites transformed navigation on Earth, These reflectors could eventually become part of the Moon's own positioning system. The third instrument focuses on one of the greatest dangers facing future lunar explorers: space radiation. Unlike Earth, the Moon has no thick atmosphere and virtually no global magnetic field to shield its surface from high-energy particles arriving from the Sun and deep space. The Linear Energy Transfer Spectrometer, or LETS, will continuously measure the intensity and types of radiation reaching different lunar locations. Using compact silicon detectors, the instrument will gather valuable information that engineers can use to design safer habitats, improved spacecraft, and better protective equipment for astronauts expected to spend weeks or even months living and working on the Moon. These 4 missions represent only one part of NASA's much broader vision. The agency already has 17 commercial lunar deliveries planned through multiple providers, and additional projects are already under consideration. One proposal involves sending a new rover known as PROMISE, the polar rover for observation, mapping, and in situ exploration. Built using technology derived from NASA's successful Perseverance and Curiosity Mars rovers, PROMISE would explore both the lunar surface and the material hidden beneath it, searching for resources that could support future astronauts. Water ice trapped near the lunar poles, for example, could one day provide drinking water, breathable oxygen, and even rocket fuel, reducing the need to transport these essential supplies from Earth. NASA is also planning entirely new categories of lunar infrastructure. Future missions may deliver power generation systems capable of supporting long-term operations, advanced avionics for future landing vehicles, high-resolution optical imagers focused on the lunar South Pole, and technology demonstrations designed specifically for permanent settlements. Another major priority involves creating a dedicated communication and navigation satellite network around the Moon. Just as satellites allow GPS, internet connectivity, and global communications on Earth, a similar constellation around the Moon would provide reliable communication between astronauts, robotic vehicles, orbiting spacecraft, and mission controllers back on Earth. Taken together, these projects reveal something important about NASA's long-term strategy. The agency is no longer preparing for isolated missions where astronauts briefly visit the Moon before returning home. Instead, every new lander, rover navigation system, communication satellite, radiation detector, and scientific experiment contributes another piece to an expanding lunar infrastructure. Each mission helps solve practical problems: how to land safely, communicate reliably, generate power, navigate accurately, protect astronauts from radiation, and locate valuable resources. These are exactly the capabilities required for people to eventually live and work on another world. The Moon also serves another critical purpose. NASA views it as a testing ground for even more ambitious exploration. Operating on the lunar surface allows engineers and astronauts to develop technologies, procedures, and life support systems that will eventually be needed for human missions to Mars. Living on the Moon will teach valuable lessons about surviving in hostile environments, managing limited resources, and maintaining long-duration space habitats far from Earth. Every challenge solved on the Moon brings humanity one step closer to becoming a truly interplanetary civilization. For now, these missions remain in preparation, with launches expected in late 2028. But their significance extends far beyond the individual landings themselves. They represent a fundamental shift in how humanity approaches space exploration. Instead of planting flags and leaving footprints, the goal is now to build permanent infrastructure, establish sustainable operations, and create the foundation for continuous human activity beyond our home planet. For generations, the Moon has inspired myths, dreams, and scientific curiosity. Soon it may become something even more extraordinary, not simply a destination, but humanity's first permanent outpost in space. And if NASA's vision succeeds, the lunar base being planned today could become the first chapter in an entirely new era of human exploration, one that eventually stretches all the way to Mars and beyond.